What's up, guys? Shelton and Arthur here, coming at you with a demo of IoT Security for MicroAI.
That's right, guys. MicroAI ingests all different types of sensor and computational data, feeds it to an AI engine, which creates an output that can be used in a million different types of applications.
So, quick disclaimer before we get started, if you have not gone through the introductory part of the SDK documentation, meaning the Raspberry Pi prep, meaning the SDK prep, installing all of those assets, please stop the video now, go back and read through that documentation. Make sure those assets are installed properly, otherwise you will not be able to go through this tutorial. And it will also give you a lot better understanding of what MicroAI is and kind of how to interact. So without further ado, let's go ahead and jump into this tutorial.
All right, guys. First thing, let's start the AI engine. So we're going to navigate to the correct directory where our security demo is located. First thing. From here, you'll see all of the required files. So we'd like to note that the model has already been trained, in this case, for 200 seconds. That was with 14 different channels of computational performance data that are confidential for security purposes. So now we can already go ahead and run the AI engine. We're going to do that with this command. And here we got it running. Next, we're going to run the two applications necessary to test with attack scripts. So first thing is going to be the initiator application that opens up a port for the attack scripts to work. To do that, let's navigate to that same security directory. And let's go into the IoT attack tool subdirectory. And let's go into the initiator subdirectory there. Here we're going to run the initiator.py file. Alright, now we got that going. Let's run the command center. Same thing, let's first go into the security directory. Let's go into the IoT attack tool subdirectory. And then let's go into the command center subdirectory. Here we will run the command center.py file.
So when we run this command center, guys, what it's going to do is actually give us an interface for submitting any of these test attacks. Again, this isn't a comprehensive list, but this should be enough to kind of get the general idea. From a data siphon to cryptojacking, you can run all of these test attacks and see how the MicroAI actually picks up this abnormal behavior on your Raspberry Pi.
That's right. Now we have the AI engine running. We have our testing setup ready. All we need to do is run some application code that uses our output, some Y code. So let's go ahead and do that. Go over here, go to the same security directory. Here we're going to go into the Y code subdirectory. Here we'll see a few different Y code files. Let's go into security Y code and see what exactly is going on in this file. So here is a short file that uses MicroAI output. It imports from the MicroAI output library the MAI class and time. It is connected to the local host, showing that everything from data ingestion to the AI engine to output is running on the edge device. And it is using the isAbnormal function that is a part of MicroAI output, which basically tells for each channel that is ingested by MicroAI, it'll tell us whether it is acting normal or abnormal, 0 or 1. So that's what's going to be printed firstly, so you'll have 14 different numbers there for the 14 different channels. It'll also print the sum of all of them, and if that sum is greater than 2, more than 2 channels are abnormal, then it will print that the device is under attack. Otherwise, it'll say the device is okay, and this will happen every 1 second. So let's go ahead and run it.
So as we run this Y code, what we're seeing here is obviously groups of zeros and ones, which essentially reads out values of normal and abnormal. So as we see the device is okay, if we run one of these test attacks, let's say flood DOS, and we go ahead and run that, we'll see a change. We'll see that the micro AI is actually picking up that the device is under attack, and then as the attack normalizes and then as it ends, we'll see that the device will resume behavior and the device will be okay again. So as you can see, this not only can be used for a Raspberry Pi, but it can also be used for any other entity or device that you would like to keep secure. I hope this prompts a lot of good use cases, a lot of thoughtfulness around how you can edit your Y code for IoT security. If you have any questions, please visit the onetech.ai website and go to the developer portal section. Again, any and all questions can be answered there. Thanks, guys. Really appreciate you watching the demo and happy coding.
Happy coding, everyone.